One more little topic that we need to cover is if something is differentiable. So when we're trying to find a derivative, before we do anything, we got to know whether a function actually has a derivative. So not all functions have derivatives at all points. So we need to know if something is differentiable on an interval. So basically the key is we're looking for a smooth graph, all right? So here's the official definition. So a function is differentiable if and only if the limit as x goes to c from the left here of the secant value is equal to the limit of this slope coming from the right. Okay, so the derivative is approaching the same value. The slope is the same coming from the left and the right. That's the idea. So here's the absolute value function. Okay, so a couple questions. What happens as x goes to 0? Well, we're going to 0. The limit is 0. All right. So the actual value of the function is going to 0. Now, what is the derivative at these different points? Well, the derivative, remember, is the slope. Just looking at the graph. What's the slope at x equals -2? Well, it's this line. The slope is going down to the right, and so the slope is -1. What about when x is +1 over here? What's the slope? What's the slope of this line? The slope is 1. And when x is 0, what's the slope? Well, that's a problem. It doesn't have slope. Okay? So there's no slope because as we approach here, the slope seems like it's going down to the left. It's going to be a -1 slope. As we're approaching here, okay, all these points have a slope of -1, -1, -1, -1. These all have a slope of +1, +1, +1, +1. Okay, so the slope is undefined because the slope coming from the left and the right don't agree. So we can say that this is not differentiable at the point 0, or we can say it is differentiable at or on the intervals -infinity to 0 and 0 to +infinity. Okay, that would be the regions it's differentiable on. So some quick keys to remember. We just saw that if something is differentiable, then it must be continuous. All right, you can't have a hole and be differentiable. Okay, it's got to be filled and it's got to be smooth. The converse is not always true. If it's continuous, that does not mean that something's always differentiable. And the example of that is this function up top. The contrapositive is true. If you know that something is not continuous does tell us that it cannot be differentiable. Okay, so keep that in mind. It's a one-way deal. If it's differentiable, you know it's continuous, has to be. So, all right, hope that helps. Keep working hard.